guys, so today we are going to continue with our probability unit, and today we are going to look at how to find the probability of events A or B occurring. So first let's look at the do now. It says if the probability of A is 0.5 and the probability of B is 0.2 and the probability of A and B is 0.10, are A and B independent or dependent? So referring back to the last lesson, we know that if A and B are independent, that means the probability of A and B equals the probability of A times the probability of B. Okay, so let's identify all of our information. We know that the probability of A is equal to 0.5. We know the probability of B is equal to 0.2 because that's given to us from the question. Now we have to find the probability of A times the probability of B. Now that's equal to 0.5 times 0.2. Okay, you can go to your calculator to do that. If you can do it by hand, that's awesome. So we're doing 0.5 times 0.2, and we get 0.1. So this is saying that the probability of A times the probability of B equals 0.1. So we have to compare that to this right here. So the probability of A and B was 0.10. So right now we have to determine if 0.1 is equal to 0.10. And it actually is. Even though this has a 0 as a placeholder, you can add a 0 to this one, or you can take the 0 off from both of them. So since 0.1 is equal to 0.10, A and B are independent. Okay. So let's move on. The addition formula. So like I mentioned before, today we're looking at the probability of A or B. So the addition formula is used when you're finding the probability of A or B. And that happens by having the probability of A plus the probability of B minus the probability of A and B. So kind of going through notation, just want to remind you that when we used and, the notation for that was an upside down U, which I said kind of looks like the N in between, and that represented the intersect. Okay? When we're looking at or, we have a U, which represents the union. Okay? So the union is what we use for or. So this is just some more notation. Remember, or goes to the U, which represents union, and becomes the upside down U, which represents the intersect. Okay, so let's just look at this example here. It says, suppose you pick a shape at random. What is the probability that the shape is round or green? First, we're going to look at it just by using the shapes, and then we're going to use the equation. So I'm going to drag over here what we want. So we want a shape that's round or green. So this shape is round, this is round, this is round, this is round, and this is round. Now we also want a shape that could be green. The only shape here that's green is this one there. Okay? Notice we're not looking for which is round and green. we're looking for round or green. So this probability, so we're just going to find the probability of round or green. So our total possible outcomes go on the bottom, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 total shapes. And of those 9 shapes, 1, 2, 3, 4, 5, 6 were round or green. So we can simplify this. I'm just going to move this over. We can simplify this. The number 3 goes into 6 and 9. So if we were to simplify by dividing both by 3, this becomes 2 over 3. So the probability of picking a shape that's round or green is 2 over 3. So now let's use the equation for it, okay? So the probability of A, or, well, before we even do that, since we're using A and B, let's identify what A and B is. So event A, let's say that the shapes are round. Event B, let's say that the shapes are green. Okay? Now I'm going to move all these back. And let's do it. So the probability, use a different color. So the probability of A or B is equal to the probability of A. Now the probability of A is the probability that we have a round shape. Now looking at all of our shapes here, this one's round, this one's round, this one, and this one are round. So 1, 2, 3, 4, 5 out of the 9 shapes are round. So that is the probability of A, 5 over 9. The probability of B is the probability that the shapes are green. So this one's green, this one's green, and this one's green. There's only 3. So 3 out of the 9 shapes are green. Now you can simplify that if you want. I'm not going to right now though. So this could be 3 over 9. Now we have to find the probability of A and B. So that's the probability that the shape is round and green. So this one is round and green. I'll use a little circle for it. This one is round and green, and those are the only 2. So the probability of round and green is 2 out of the 9 shapes. 2 over 9. So now what we're going to do is we're just going to plug that whole thing into our calculators. So I'm going to pull it up. We have alpha y equals, the first fraction was 5 over 9. So 5 over 9. Then we have plus 3 over 9. So again, alpha y equals 3 over 9 minus probability of A and B, which was 2 over 9. So 2 over 9. And then we press enter, and we get 2 over 3. Notice it's exactly what we got before. Okay? So moving on, before we get to some problems, the way to identify this is the keyword of or. Okay? So now let's get to some examples. So example 1 says, at Maspeth High School, a student can take Latin or Mandarin. About 37% take Mandarin, while 48% take Latin, and 5% take both. What is the probability of a student taking Latin or Mandarin? So that or tells us to use the addition equation. and the addition equation I wrote above. So first things first, let's identify event A and event B. So let's say A is Latin. Let's say that B is Mandarin. Okay? Now we are going to use the equation, the probability of A. I'm going to use the notation, so OR is union. A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so we need to find the probability of A. So the probability of A, which is a student taking Latin, is 48%. Now we don't like using percents in our equations, so we're going to change that to a decimal. To change it to a decimal, divide by 100 or move the decimal place. So it becomes 0.48. So I'm just going to plug that in for now. Probability of A or B equals the probability of A, which was 0.48. Now we have to find the probability of B. So the probability of B, let me move that over a little bit so you don't get confused. So the probability of B is the probability that they take Mandarin, which is 37%. We don't like it in percents, so we're just going to change it to a decimal, which is 0.37. Okay? And now lastly, we're going to find the probability of A and B. So A and B. And they say that it's 5%. Okay, so this is 5%, but we don't like it written as percent, so we change it to a decimal, which is 0.05. So minus 0.05. Now we're going to type all of that into our calculator. So pulling that back up, we get 0.48 plus 0.37 minus 0.05. So enter, and we get 0.8. So this is equal to 0.8. Or you can change this back into a percent if you'd like. So this can be 80%. You can also change it to a fraction if that's what you like the best. So any of those two will be a possible answer. So what this means, I'm going to write an explanation next to it, is that the probability of students taking Latin or Mandarin, can I fit it? Yeah, is 80%. Okay, so moving on to example 2. It says that Maspeth High School has 480 juniors. Of those juniors, 333 take Algebra 2, 306 take Chemistry, and 188 take both Algebra 2 and Chemistry. How many juniors are in Algebra 2 or Chemistry? So OR is our key word here. So it's the key word to use addition equation. Okay, so we are going to need to use the equation, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so we're going to need to identify what A and B is. So let's make A Algebra 2, which is your favorite class, I know. Let's make B Chemistry. And then let's begin. So we're finding the probability of A or B. Okay? So first let's find the probability of A. So the probability that someone takes Algebra 2. Now we have to do a little bit of work here because it doesn't tell us exactly the probability. It only tells us how many juniors take that class. So what we have to do is make it a fraction. So the total number of juniors goes on the bottom, which is 480. And the number of those juniors taking Algebra 2 goes on the top, so 333. So that's the probability of A, 333 over 480. I know it's a big number, but don't be scared by it. Now let's find the probability of B, which is the probability of chemistry. Now 306 of the students take chemistry, so 306 out of the 480 juniors take chemistry. So 306 over 480. Now let's find that last probability. So the probability of A and B. So that's both Algebra 2 and chemistry. So 188 of all the 480 juniors take both of those classes. So this is 188 over 480. So let's type this right into our calculator. So alpha y equals, enter to get our fraction. We have 333 over 480, whoa, it's not supposed to be that, over 480 plus alpha y equals, then we have 306 over 480 minus, again, alpha y equals, and we have 188 over 480. Press enter and we get 451 over 480. So the probability of A or B is equal to 451, right? Yes, 451 over 480. If you want to write a sentence, you can. Okay, moving right along. Let's get to another example. It says, given events A and B, such that the probability of A is 0.6, the probability of B is 0.5, and the probability of A union B is 0.8. Determine whether A and B are independent or dependent. Now this problem, there is a lot that goes into it, okay? So to determine whether A and B are independent or dependent, what we need to do is determine if the probability of A times the probability of B is equal to the probability of A and B. So that happens if they're independent. Now we did a question like this on the Do Now, but they don't give us A and B. They give us A or B. So I'll just write this here. I'll rewrite it as A or B. But if we look at our equation has the probability of A and B in there. So what we have to do is we have to solve for the probability of A and B first, And then we're going to use this information here to determine if they're independent. So let's start with our equation. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, let's start filling in some information. The probability of A or B, that's 0.8. The probability of A, they tell us, is 0.6. The probability of B, they tell us, is 0.5. And we don't know the probability of A and B, so we're going to label that X, because that's what we're trying to find. So now it's just a simple equation that we can solve. First thing we should do is combine like terms. So we have 0.6 plus 0.5. You can use your calculators for this if you're uncomfortable with adding decimals. I don't know why I clicked the division button, but that is equal to 1.1. So when we combine these, we get 1.1, and I'm going to bring everything else down, is equal to 0.8 minus x. Again, we're still solving, so what we can do now is subtract 1.1 on both sides because we are solving for x. Again, if you're not comfortable, use your calculator, and you get negative 0.3. This is negative 0.3 is equal to, we're going to bring down that negative x. Notice x is not by itself yet. It still has this imaginary negative 1 in front of it. So we're going to divide both sides by a negative 1. And here, negative 0.3 divided by negative 1 is just 0.3. And we're left with x. Now remember what this meant, okay? In terms of our question, x represented the probability of A and B. So this means that the probability of A and B equals 0.3. Now let's determine if it's independent or dependent. So I'm just going to draw a little line there and do my independent-dependent work here. So the probability of A was 0.6. The probability of B was 0.5. Now we have to find the probability of A times the probability of B, which is 0.6 times 0.5. Okay, squeeze it in there. So the probability of A times the probability of B is equal to, again, if you're not comfortable, just use your calculator. Equal to 0.3. Now the probability of A and B was also 0.3. So since 0.3 is equal to 0.3, that's correct. That tells us that A and B are independent. Okay? All right. So to get credit for this class, you have to answer this question on a separate piece of paper and show all your work, and you are going to upload it to the Google Classroom. Okay, everybody, have a great day.